Okay, so good morning. Okay, so let me share my screen. So I'm audible, online team. Can anyone please confirm? Thank you. Okay, guys. So Docker day 2. Yeah. So what is Docker, guys? What is Docker? Hmm? Hmm. Hmm. So containerization tool. What is containerization? Yeah. Containerization is a process to host an application. So by sharing the hardware from the host machine. Okay. And the respective environment we can call from the Docker Hub. Okay, it's a lightweight images. Only the specific, the required dependencies only we can add. Okay, so the whatever other dependencies we can customize by using Docker file. So in the Docker day 2, I think Docker introduction already done, right? So if required, I will share the recording also, Docker introduction. You just go through today also once. So now the Docker day 2, I'm going to show you some Docker commands now and how to work with Docker and all I will show you. So if I want to work with Docker, I should have a one EC2 instance, right? So on top of the EC2 instance server, I'm going to install Docker. Clear? So T2 micro is enough, guys. No need to create T2 medium. For Docker, T2 micro is enough. So let me launch a server. So guys, this is very important concepts. So once again, I'm saying, whatever if you are any concept set to complete, you just start from Docker first. Later you can plan the pending concepts. So you can stop the practice on other topics. Start only Docker from today. If you are lag some other topics, you can plan later. Okay. Okay. Let me launch one server. I can launch T2 medium. So you can launch T2 micro only. Sunday holiday only. Sunday, Sunday always holiday. No workshop. Monday, not at confirm. Proceed without key pair. Launch server. Let's go to security group. Connect the server. Okay. So how to install Docker first? M install docker-y. Clear now? So next is what? I have to start the Docker service, right? In this case, systemctl start Docker. Okay. You can check status also, Docker status active. Clear now? So you can check Docker version now, hyphen version. Yeah, 25.0.8 is the version now. So if you can check only version, you can see client server status, right? Client server status. I have already discussed in the day one Docker architecture, right? Client and server. Daemon is there in between. When you ask any request, first it will check with the daemon. If the images are there, it will give back. Otherwise, it is redirecting into Docker Hub, right? Yeah. So now we can discuss the commands. So if I want to work, for example, okay, what I'm going to do now, first I'll discuss sample commands in the Docker, then I will show some use case for today. So tomorrow onwards, we can start Docker file concepts and all. Okay, important. For example, I'm going, okay, let me open the Docker nodes also. Yeah. So this is installation process. I mean, for example, if I want to run Docker ps command, I can see running containers. So if I switch to EC2 user, if I run Docker ps, I'm unable to run this command from EC2 user. I'm able to run only from root. In this case, you can do one thing also. So you can create a Docker group, but already group is there. So what we can do, add EC2 user into Docker group. Clear how to add user into group? User mod -a-z Docker EC2 user. EC2 user is going to be added to the Docker group. Done. So Docker is which type of user, guys? I'm running just execution permission also here. I mean Docker daemon execution permission, docker.sock is execution permission. So New grep Docker means the changes will be applied immediately. Now you can run Docker PS command. See, I'm able to execute the same command. So if ECT user, what is the command to check a groups? Command is not wrong. Oh, sorry, spelling is wrong. Say again, see now, Docker ECT user into same group. So that ECT user able to run Docker commands. Clear now? Yeah. You can see these are the list of users. Sudo su hyphen. Oh, is it? I'm a little bit fast. Okay. Okay. Clear till here now? Clear? So I have installed the Docker now. So I have installed the Docker. If you want to run Docker commands through EC2 user, the Linux commands already discussed, right? So whenever you can install Docker or Jenkins, system users will be created. You can add that system user group EC2 user also. So that EC2 user got a permissions from Docker. So EC2 user able to run a Docker commands. Clear the concept now? Yeah. So from the root, we can run any Docker command. But from the EC2 user, if EC2 user having permissions only able to run Docker commands. In this case, EC2 user has to add into the Docker group by using Linux commands. Okay. Okay, guys. The first command now, the Docker pull. After install, the first command of Docker is Docker pull. Okay, please don't write, focus. I will explain tomorrow. Each command on the notepad, I will share it to you also. Okay, each command I will explain tomorrow again for revision purpose. Okay, Docker pull command. It will pull image from where? Docker hub. This request will go to where? Docker daemon, right or not? If you can see, this is Docker server. Client means my EC2 instance from where you are running a commands. So I'm running now command, for example, Docker PS, Docker pull. This is client now. Client interact to Docker server. See, my Docker server up and running, how to check? Give version only, not hyphen hyphen version. If you give version, you are able to see server is up and running. If this server is not running now, you are able to see only client only here. And server, you can see here error. In this case, you are unable to interact the Docker server, Docker daemon, so that you are unable to work with Docker. Clear now? So whenever I can run a command, Docker pull command, the request will go to where, guys? Docker daemon means Docker server. Docker daemon also part of the Docker server. So the request will go to Docker daemon. Docker daemon will pull the image from where? Docker registry. And if I run image, container will create. Right or not? Yeah. You can see. Clear the concept now? So I'm here, Docker pull request will go to Docker daemon redirecting into the registry. What is Docker daemon? Is a server. It's a controller between client and registry. When you install a Docker, this Docker daemon will come. It's a controller. Okay, let's go to now understand. Yeah, on top of hypervisor, VM is hypervisor layer only, right? On top of that, we are installing Docker OS. So that is server. Yeah. Hey, this is your first class? Who is this? Nitin, this is your first class? How? First class didn't explain. Is it right? In my Docker day one, I explained or not this concept? Hmm? Practical also I have already shown, right? This concept practical also I have shown. Uh, this concept I have explained day one. I think I have shared screenshot also. So now do I need to repeat Docker concept again? No problem. Tell me so that I will repeat. Okay. Okay. So guys, when I run Docker pull command, the request will go to Docker daemon first. Okay. The default Docker place also I have discussed where lib Docker. Okay. So now, okay, my Docker is running on my EC2 instance. Okay, my Docker is running on EC2 instance. So first today we will see the Docker commands, how to pull a image, how to run a image, how to check a containers, how to log in as a container, and all we can see. Okay, when I run Docker pull in Nginx, I'm just taking Nginx process. Even I have shown Jenkins also, right? I have shown Jenkins also, right or not? Through Docker first day I have shown Jenkins. I think you guys are not practicing. I can't do anything. Okay, Docker images. I have explained day one Jenkins also. I have shown how to take password also from inside container. I have shown what and all process are running inside the Docker. And also I have shown what and all process are running inside EC2 user. There we can see more process are running. Here only we can see two process are running. I have shown everything. Without practice, simply you guys are postponing the work only. See, if you are postponing means what will happen? The course will be extended. Always 6 months, 7 months. Okay. Okay, leave it for whatever class I have explained. Let's start from the scratch again. Okay, so Docker day one. So Docker is a containerization tool. Okay, Docker is a containerization tool. So if where we can use this Docker process, if I want to deploy a multiple applications on minimum servers with less resources, so we can take a Docker as an option. Okay. So in that case, my and 10 applications are there, for example. What I can do, so first I can create a EC2 instance. So this is hardware, this is OS. So on top of that, you can install Docker. Okay, you can install Docker. So now this Docker, for example, yeah, this is enter EC2 server. Okay, now you have connected this EC2 server, right? Inside Docker is running. Okay, so to connect this Docker, what we can do? Run a Docker commands. The Docker commands request will go to where? Client means EC2 user to Docker. This Docker is redirecting into Docker registry. Here client means what? Client means what? Where your Docker is running. Understand? Client means from where you are running commands. It's a client. Server means what? From where this request is initiate in the Docker server. Now in this architecture, if you can see in this architecture, client means what? Where you are running a commands. So client means here EC2 instance. You have connected EC2 instance, right? Yeah. And your Docker is running on where? Docker host. Host means what? Your EC2 instance inside Docker is running. And where? EC2 OS. So your client interacting to Docker, I need a image. Which image? Whatever image you can ask, Docker will check first my end any images are there previously built. No, this is fresh request, images are not there. Then it is redirecting into Docker registry. Docker registry is here. So Docker registry. Docker daemon redirecting into Docker registry. Okay, whatever image you can ask, that will pull from here only. So for example, if I run now, okay, Docker pull Nginx, request will go to where? This is client, right? Request will go to where? Server first. Request will go to Docker host, Docker daemon server. Here, Docker daemon will check if it is not there, redirecting into here registry. Clear now? So now I'm going to run Docker pull Nginx. Okay, I'm going to run again Docker pull Nginx. I'm going to run again Docker pull Nginx. So the request is not redirecting into registry. But first time, if you can see, redirecting into registry, pull from the registry. But second time, third time, fourth time, second time, third time, fourth time, the request is not redirecting into registry. First time only redirecting into registry. When the images are stored inside the Docker already, so second time if you run image already there, take it. Third time image already there, take it. Until you run new image, request won't go to Docker registry. Now see the difference. I'm going to run Docker pull, different image. This image is not there in my end, right? See, extracting from Docker registry and again stored into localhost and Docker daemon. Clear now? Yeah, this is the concept. Okay. Now, the first command is what? Docker pull. Let me write here. Docker pull image name. Okay. So, okay. Now, if you want to check you whatever images you pull, Docker images. Understand? Docker images. See, my end, I'm able to see only the images in Nginx and HTTPD. So now if you run Docker pull again in Nginx, again you can check Docker images. Still same Nginx image, only one image is only there. Understand? If you run multiple times also, Docker host is saying that this image already there. If you run six times request is not taking from the Docker Hub registry, right? So system is saying, I think you don't know image is exit already, so image already there. Yes, it will take from the Docker system itself only. Docker will store in the local varlib Dockers, right? It will give from there only. This image already there. This image already there. Now again, for example, if I give different image, for example, you can give anything, Ubuntu. Ubuntu is a OS image, right? Docker pull Ubuntu. This is what client I'm running I'm running commands inside the client. This request is redirecting into my server. See, pulling from library Ubuntu. If you run again, see Docker images. Now you can run. Only 2 times I ran, but only one Ubuntu is there. Understand? So now you can see this is created 6 weeks ago. I mean updated maybe in the Docker end. Okay. So HTTP is updated 2 months ago. Same Ubuntu is updated 8 weeks ago. This is image ID. This is latest tag. This is sizes. Clear now? Okay. 2 commands I discussed so far. One is Docker pull and second is how to check pulled images. Okay. Okay. Now, so now guys, the life cycle, Docker life cycle, first we can create an image or take image from the Docker Hub registry. Next is what? If I want to give this image access to someone, means what should I do? Create a container and give access. For example, understand very careful. Your and AMI is there. The AMI is some inside OS plus application AMI is there. AMI, I mean, server inside Ubuntu is running or something, Nginx is running. After that, you have created a AMI. Your and only AMI is there. This AMI inside application is there. If you want to give access this AMI to someone, what you should do? So my end, AMI is there. Amazon mission image. Okay. So now users are here. So this application AMI inside OS plus application is there, right? So I want to give this access to users. How to do this? This is which format? Image format. AMI is a image format. Any application is running inside image? No, application is there only but not running, right? To run this process, what should I do? To run this process, I should have a OS plus hardware, right or not? Then only application can take a hardware and OS. It will give response to user, right or not? In this case, what should I do? AMI, from AMI, what should I do here to give access to users? Create a server. Very good. Create a server. Finally, if you take any image, finally you have to create a server only, right? Create a EC2. From where? Custom AMI. From where? Custom AMI. Okay. After that, give access to through load balancer or something to your users. Clear now? Now you tell me, guys, my end Docker image is there. This is AWS. Huh? This is AWS. My end Docker image is there. Docker image is there. Same. I want to give access to end users. In this case, what should I do? Create a container. Clear the difference now? Process is same, but this is, you can understand, this is small server. Container means small server. Very less size server. Customizing server. Yeah, so container. Okay. Now, so this is container. Created a container from Docker image. Create a server from AWS image. Is it possible to create AWS image to container? No. Is it possible? Oh. Is it possible to create Docker image to EC2 instance? No. Clear the concept now? Yeah. Here you can see number of dependencies are there. This is EC2 instance. Python dependencies, Java dependencies, EC2 libraries, Linux libraries, default process. But here, if you add, only the process will run. Otherwise, whatever image you can take, same image size only, container also there, mostly. Clear the concept now? Now Docker registry. So this AMS will give, this AMS will get from where? This AMS will take from where? AWS. No, no, AMIs, AMIs, not Docker images. From AWS, right? AMS will get from AWS. What about Docker images? Docker Hub, Docker registry, or whatever. Clear the concept now? Now AMIs, we have a custom AMI, default AMI, right? You tell me, guys, you tell me simple logic. Slowly I will take you into the subject now. This is default AMI, means whatever AWS is giving, those are the default AMIs. Now you tell me simple logic here, concentrate 10 minutes, you can easily understand. Now you tell me, if I go to Docker, now let's close this all unnecessary tabs first. Concentrate, very interesting now. Okay. So let's go to Nginx. You tell me this image is Docker providing default image or not? Like AWS providing AMIs? Okay. Okay. This is clear, everyone, right? Okay. Now, I want to let's take the process here. Yeah. Okay. For example, this is default AMI. This is also default server only, right? Default AMI Ubuntu image means you can create Ubuntu server only. Clear now? But I want to create a custom application. In this case, what you can do from this AMI, you can create a server. But this AMI is default image, right? In this case, what you can do again? From the default image, you can create a server. Yes, exactly. From the default image, you can create a server. What we did. So, yeah, concentrate now. Now I want Python application. Okay, this server is now, which type of server now this is? Default server. Nothing is there inside. Why? Created from default image. Created from default image. Now, inside my server, I'm installing minstall Python. After that, I'm copying code into Python library. Copy code or git clone. And after that, I'm going to run Python application or install dependencies. After that, I'm going to start. This is the process, right or not? Now, this server, from this server, can I create custom AMI now? What is custom AMI? After you are adding some dependencies, some custom actions, now you can create a AMI. Yeah, this is what custom AMI. Clear now? From the custom AMI, what you can do again? Create a multiple servers, right or not? Create a multiple servers. Now this server difference is what? This is just only before Ubuntu server. After that I have installed. Now this server directly application is there or not? Directly. You no need to run anything inside now. Why? Custom image inside only you have created. Application already running now. Correct. Clear now? This is the process what you already done before in the AWS classes. Same process how to do in Docker now. Okay. Same process. Let's go now. Okay. See guys now. Now directly I'm taking Docker Nginx image. Okay. Now if I run, container will create. Which container this is now? Nginx container. So they can access what? Nginx. Clear now? Okay. Now, same logic I can apply. Okay. I'm taking now Ubuntu image, direct Ubuntu image. Okay. Now I'm taking direct Ubuntu image. So from the Ubuntu image, if I run container inside only Ubuntu only run. So nothing is there to access here. Nothing is there to access here. Clear now? Now I want to do, see, some application now. I want to deploy some application. This is default action, right? Like EC2. In EC2, you have installed manually and create a custom VM, right? Now, this process also, see now, I want to deploy now Python application. Okay. I want to deploy now Python application. Okay. Let me decrease the size. Yeah. Focus now. This process is what now? Custom process. In custom process now, I want to deploy Python application. In this case, what should I do now? I'm taking Docker image Ubuntu, only Ubuntu. So Ubuntu is there means same like first default Ubuntu EC2 or Amazon Linux EC2. After that, what you did? Install required dependencies. Then created AMI. Now this is also default Ubuntu. If I run default container will create, right? For example, now default container will create. After that, what you should do? Now default container is running. Default Ubuntu container is running. Like default server, right? After that, what you should do? Log in this container. Why Nginx? I'm talking about Python, right? Log in this container. Install same steps, right or not? Install same steps inside the container and give access to user. This is the process of Docker. The only the difference is what here and there. Here Amazon instance, here Docker container. Here Amazon image, Docker image. Here image size is 6 GB, 8 GB. Here image size is 200 MB. Here lot of dependencies are there. Nothing is there. Clear the difference now? But now the simple question. Can I, my and 5 servers are required. AWS EC2 servers, 5 servers are required. So instead of create a server and log in and install dependencies for first server and run application, and again connect second server, install dependencies, run application. What we can do, create a one server, take AMI, we can do it, right? Same here also. How to create a custom image like here, right or not? So here what we can do, instead of that, you are preparing your custom image now, right or not? Plus in custom image means inside application also. So for that I'm taking a base OS, right? Base OS also have taken and created a server. After that you have installed the dependencies and Python and all. Now my end only base OS is there. After that what should I do? Here install Python, install dependencies, run Python. This is the process, right? Copy the code also. Copy the code also. Okay. Now, okay, in this case, what we can do, this is now custom image now, including dependencies. This custom image, if you can run, what will create? Container will create. Now this container create from base image or custom image? So in this case, container inside application there or not? No need to log in your container, right? Container inside Python application is there. Clear now? So this custom image creation process is there, right? This is called Docker file. Clear? This is called Docker file. Understand the difference now? But here, there is no file concept. Log in the server, install dependencies, take a custom image. But here, once you deploy Docker Hub, once you deploy Docker default Ubuntu image and create a container and log in a container and install dependencies, also we can do. But this is not automation process, right? In this case, if you need a 5 containers, you should log in every container and deploy, install dependencies and run again. This is not a good practice. Make it ready your image before run a container. Make it ready your image before run a container. The make it ready image process is called Docker file process. Clear now? Yes. Artifact. Nice. But now to create a custom image, I should have a base image or not? Custom image means, for example, to create a custom AMI, you are taking from where? Default image only, right? Default image to default server, then dependencies, then custom AMI. So here also to create a custom image, these dependencies to run, I need a one base OS, right? Ubuntu or Amazon Linux. That's what I'm taking one Ubuntu OS. On top of the Ubuntu OS, I'm installing a dependency. Clear now? Okay. Now the requirement. I want to deploy Python application on EC2. Same thing container. Come on. I want to deploy Python application on Docker. Clear the concept now? Okay. You tell me now steps. What I need to do first. EC2 process only. Leave about container. EC2 process. What should I do now? First. Huh? Okay. Login account. Okay. Log. Guys, from the scratch I need. Directly don't go run Python. That's what. If you understand from the scratch, the process is you can easily understand. Okay. Let's wait. First step is what, guys? Create EC2. Right or not? Create EC2 step. This create EC2 step start from where? Selection of AMI. Which OS you want. Clear or not? So I'm taking Ubuntu. Ubuntu AMI. Clear now? Ubuntu AMI. Okay. In this case, from the Ubuntu AMI from the Ubuntu AMI, you created a server now. Clear na? Okay. This is hardware. This is OS. Which OS this is now? Ubuntu. So here only Ubuntu dependencies are there. Many dependencies are there. Many dependencies are there. Clear the concept now? Now I want to deploy Python application. In this case, what should I do first? Install Python. Next is what? Copy the code. Copy code. Next is what? Install dependencies. This is the concept right now. Right? Okay. Let's go to users now. Now only they can access your Python application. Clear? Clear everyone? Now you tell me the process on Docker. Okay, anyway, one server is required to run on Docker. One server is already there, Docker is running. Tell me now. First, from the scratch, very good. Docker image Ubuntu. Right or not? This is taking from where? AWS. Okay. Now, next is what now? Go to Docker Hub registry. Take a one default AMI kind of process. Means Ubuntu. Which OS you need? Ubuntu OS. Okay. So let's take now Ubuntu OS is ready now here. I'm preparing a container. Okay. I'm preparing a container. Okay. Which type of container this is? Ubuntu. Right or not? Ubuntu OS container. Okay, keep it like Ubuntu OS. Next is what? Okay, now Ubuntu OS is ready. Okay, so this is Ubuntu OS image. Next is what? I should write a Docker file to create a custom image. Right or not? To create a custom image. In this case, write a Docker file. If you run container directly from the Ubuntu container only create. But I need my application container. So take a base image, install dependencies. Okay. I'm writing a Docker file. Here first, what should I do? Take base image Ubuntu. Clear now? Yeah. Next is what? So image is ready. Here also default image is ready. AMI. Okay. Next is what here? Install Python. Python installing on top of Ubuntu. The meaning is now. Next is what? Install dependencies. Right or not? Or copy the code. Next is what? Run Python. Clear? So run Python. This entire instruction process is called what? Why we are creating a Docker file? For custom process, custom application deployment. So your application Docker Hub don't know, right? They won't provide your application directly as image, right? This is your custom requirement. Take base OS and prepare your application. Create one more image. Same like how you created a default AMI to custom AMI. Here also default base OS. On top of that install dependencies, create a one Docker file. Now Docker file is there, right? If I build a Docker file, Docker image will create. This image called what? Custom image. This image is called custom image. Now this image contains what? This custom image contains what now? OS plus application plus dependencies. Can I say ready to run? Ready to deployable code? Yeah. Now how to run? If you run, what will create? Container will create, right? Now container contains what here now? Ubuntu OS plus dependencies. So whenever you can deploy this application now, application will run on OS. Which application it is? Python application. So whenever you can run this process, what will create? Server will create, means container will create. Clear now? Now this container contains what? Python application plus Ubuntu OS plus dependencies. What about this here? Hardware. From where hardware will take? Where the Docker is running. Simple. This Docker is running on EC2 or VM, any VM. Where the Docker is running, inside one container will create. This container hardware shares from this container will create on one host machine, right? The host machine is either EC2 instance or Azure VM or Google Cloud VM or normal server also. Clear, no? So this process running on where? Docker host. This Docker host running on where? One EC2 instance. Clear, right? So Docker running on, for example, EC2 instance means. So EC2 inside OS is there, hardware is there. This hardware will share from your container hardware. Host hardware. Clear the process now? How to do this now? So why we can use Docker file? Why we can run container? Any questions from anyone? Very easy. Yeah? I will never disappoint, guys. You don't worry. Okay. Now you can see Docker concepts you can easily understand. Okay. Now you tell me my end. No, you can take latest image only. Only hardware dependencies. OS we are taking directly from Docker Hub. OS is not shared from host OS. Clear? Let me show you now. So now you can understand. See, very easy way. I will tell you. My end, how many images are there? 3 images are there. If I run container, how to run? Docker run Nginx. Nginx container will run or not? No. Nginx container is interacted to my EC2 instance now. Right or not? So before running any container, we have to give the flag process here. Control C. Now my container is running, for example, Nginx container is running now. From where? Docker image, Nginx image. Now container is running on where exactly? Docker. Docker is running on where exactly now? EC2. Clear? Now my container is taking, for example, 500 MB. The 500 MB sharing from where? EC2 hardware. Okay, EC2 hardware. From here only. For example, my end, I have created 100 containers. 100 containers created, each container taking a 500 MB means I need a 20 GB. Will it support not 20 GB? My EC2 will support for 20 GB? No. In this case, what should I do? Increase the volume. Increase the hard disk EBS volume. External storage, add the volume. Right or not? Okay. So this volume provide from where? Who will provide this volume now? AWS. Clear now? So here there is a limit till 16 dB. You can immediately extend. AWS provider, they can give a volume to you, hardware to you, that you can use for your container. Clear now? So to run a container, need some RAM CPU, right? If I'm taking a T2 micro, my T2 micro is not sufficient to provide a RAM CPU. Then what should I do? Increase the instance type. Performance is different, storage is different. If you increase 1 TB data, still your server is T2 micro, there is no meaning in that. To process your storage from the hard disk, CPU should be more. To process multiple hosts, RAM should be more. So everything should be parallelly, we can increase general purpose storage. Understand? Yeah. Clear na guys, still here? Okay. Now, my end, so I'm going to discuss few commands now. Before running a Docker na guys, understand this point. If you run Docker without any specific flag, the Docker container will interact to directly host. See, container is running directly interact to host now. If I give control C, what will happen? Process will kill, right? So container, we have to say that some different flags to run, not on EC2, directly interact OS. Docker run -dt. So in Linux, Python, when I running Python, it is interacting to EC2 or not at the time. So what we did, we ran no hub command, right or not? Don't interact to server. So run background. Node.js also, we use PM2, process manager tool, right? The background. So here also we have to inform to container where it has to interact. If I run Docker run -dt means detached terminal, not interact terminal. Understand? Detached terminal, hey Nginx, you can run but not interact to EC2 OS. Detached terminal. Okay, I will run. Clear now? So before process, now this process difference is there. Before process, Nginx has started but interact to EC2. When you give control C, the process will kill. Now Docker run -dt process will run background, not interact to host. See, This is what? Container ID. Container ID. Now, how to check my containers? Docker ps command. Docker ps will give only running containers to check. My container is running or not? Running. Docker ps will show only running containers. Clear now? My end, how many containers are there? Just small questions to all. So we will go deep dive tomorrow onwards. My end, how many containers are running? One. Container is running on where? Docker host. Docker host running on where? EC2. Container hardware shares from where? EC2. Container OS takes from where? Docker Hub, not from host OS. This clarity is there, right? Very important. Only hardware will share, not OS. Now, yes, my container is running. This is default container. I want to create a custom application container. What should I do? Create a Docker file, whatever action you require. That Docker file inside give a commands and create a again image. See guys, Docker file to, am I able to run container directly by using Docker file? No. We need image. That's what again we are creating image. Clear? Image to base image to custom image to container. Base image to container, if you create base container, only will create base image plus dependencies. Base image indicates what? Which OS it is. Your Python, your Java, your Node.js should run on which OS, so that you can take a base OS. Base OS plus instructions is called what? Docker file. Clear? Why Docker file? I don't want to create a default container. What is the use? I want to deploy my application. Then create a Docker file. Then build a image again. Understand? Which image? Custom AMI, custom image. Then create a server, create a container. What is the difference between server and container? Server contains more dependencies. This container contains only your dependencies, Python plus OS only. Clear now? Yeah. Small example. Small example. Let's take okay. This example is, guys, this is ice cream. You know ice cream, right? This is empty cone. Okay, this is empty cone. So here some toppings are there, nuts. Some toppings are there. Okay. So now, whatever topping you require, you can add here. Whatever flavor is required, you can add here. So you can pay for what only? This topping, this flavor, this cone only. Right or not? Now, if you can go to a shop, the ice creams are available ready-made already. Right or not? The ice creams, for example, already toppings are there. Already nuts also there. If you say to ice cream shop owner, I don't want these nuts, can you remove? I will pay for only this. They will agree. No. So here you are customizing the process by writing a Docker file. Whatever dependency is required, you can pay for that only. You don't eat, right? Then don't take. Don't pay. No need to pay. So, but here you have to take it. But I don't like this. Still you have to take it. I don't like this nuts. Still you have to pay. We can't customize. This is not customizing shop. Understand the difference now? So this is EC2. This is Docker. Clear now? This is the process to understand. Clear? Any questions now? Okay. My EC2 inside the container limit depends on what? My EC2 containers limits depends on completely your host mission. Why? Sharing hardware from there only, right? My EC2 hardware depends on AWS. You can increase whatever level you want EC2. They will take care. But if you increase the containers RAM, container CPU, container hard disk, EC2 should take care. But EC2 is occupied with 3 containers. Fourth container I want. Then first increase the EC2 hardware, CPU, RAM and all. Then again create a one more container. I will show all the use cases. Clear? Okay. So now my container is running, right? How to check running containers? Docker PS. Okay. We have a one more command. Docker PS -a. It will show running plus exited containers. Means stopped containers. Clear or not? I want to show only stopped containers. Only stopped containers. PS is what? Only running containers. PS-a what? Running plus stop. Don't say stop. Running plus stop. See here, I can see this is running mode now. How do I know? Status is up. This is what? Status is exited. I want to see now. My container only stopped containers. So, okay, Docker PS-a, give pipe symbol, grep, which state? Exited state. E capital, right? E capital. Now you can see only stopped containers. What is the command of top in Linux? Top command. TOP. You can see CPU memory usage. Each process, how much RAM, how much CPU it is taking, you can see. My NC now you can see Docker process is running, taking some CPU RAM. If you want to see my container process, my container memory and all, login container, give top command there. Understand? But definitely it won't work. Why? Why? Top dependencies are not there in your container. Right or not? Even you are unable to run VI command also. VI dependencies are not there in your container. You are unable to run ping command, unable to run calendar command, unable to run. Nothing will run in your container except Python plus base OS. Right? Not required. Right or not? Not required. To deploy my application inside the container should run only Python command only. Not required these many unnecessary stuff, tree command and all. That's what we are reducing the size. Reducing the size, tell me the benefits now. I will close the session. Reducing the size, what kind of benefits I will get? Cost, okay. Performance, guys. Lightweight means number of processor running less means that container will give response quickly. I will show the response also here. My container size is now 100 MB. I want to deploy 1000 applications. Is it possible on single EC2 or not? Yes, possible. 1000 applications, yes. You no need to create 1000 servers now. One server is enough. Plus one standby server. If this server will fail, 1000 applications will down, right? One more server. This orchestration will take care by Kubernetes. 1000 containers you can give me, I will create. And also, I will create one more node. Same 1000 I will ready to maintain like a standby. If something is happened, the server will run automatically. That will take care by Kubernetes only take care. Yes, like cluster. Kubernetes only take care. Number of containers orchestration, how many required, how many delete, which node, which node delete, which node create, everything taken care by. Next concept is Kubernetes. Clear today? This is just intro only. Tomorrow onwards we can move. So please come offline, whoever near to institute. So Docker Kubernetes, very important concepts. 10 years, these concepts will always run. Coming 10 years. Okay. So 10 years or 15 years, you don't need to again skill up Docker Kubernetes if you learn. Okay. So understand now the situation, the importance of the Docker Kubernetes. Thank you.